In real life, many present value problems have a large number of terms, possibly even an infinite number. It's because we often have to determine value estimates for long-lived projects or firms. For all practical purposes, such a firm may even last far beyond our own lifetimes. It turns out we have a couple of guidelines of how to deal with this. It'll even give us a first assessment of what we might expect to receive investing in the stock market. We'll start with a concept called a perpetuity. A perpetuity is a stream of cash flows that goes on forever. This may sound impractical, even absurd, but it's not. It's in wide use. Perhaps the most common use is to assess a terminal value for a firm, an assessment of what you will be able to sell it for at some time in the future. For example, you may have a great new startup firm. It needs to be valued by a venture capitalist, by analysts, by potential investors. Typically, we make some projections what the firm will do over the next few years in its super fast growth phase, and then we project it as if it were just stable forever. What's the value of this stable forever? What's a reasonable back of the envelope for which we can sell the firm at that point? You guessed it, we're going to use a perpetuity. So let's review briefly where we are. We still assume a perfect capital market, no differences in opinion, no taxes, no transaction costs, no big sellers or buyers, infinitely many potential buyers and sellers. We again assume perfect certainty, so we know what the rate of return is on every project, and we still assume constant rates of returns per year. If your pro forma tells you you will earn $5 million profit in 8 years, maybe your firm will be stable by then rather than growing. At this point, we will assume that your profits will be growing just with inflation and the firm will go on forever. The value at that point is called the terminal value. You can imagine it to be the sales price at that moment in time, and we're going to discount it back, of course. Now, eternity, perpetuity. How old is the universe? Well, we are thinking it's about 14 billion years. Your firm isn't going to be around that long. Solar system is about 4 billion years. Life, multicellular life is about 600 million years. Humans, modern humans, well, ancient humans have been around for about 2 million years. Modern humans, the only Homo species left, is around about 200 to 300,000 years. Your perpetuity is never going to last that long. Also, don't kid yourself, love doesn't last forever. So this is also not what we're talking about here. How long will firms last? How long will Google last? What institutions have even survived just 1,000 years? It's very, very few. Well, the Catholic Church has survived for about 1,000 years. It's hard to think about any organized institutions that have lived longer than 1,000 years. The kind of companies that we're talking about here realistically is 50 to 200 years. So if you look back in time, even just 200 years, there's almost no companies left. Even companies like Google in 200 years almost surely will not be around anymore. So, for goodness sake, don't take perpetuity too literal. It is for back of the envelope estimates. And by the way, if we say, well, the firm will no longer be growing in 8 years when it will have profits of about $5 million, the fact is it's already a Hail Mary that it will make $5 million profit in 8 years. On some level, it's ridiculous. This whole valuation estimation approach sucks. But let's face it, there's nothing better. In the land of the blind, the one-eyed man better have a good eye doctor. For notation practice, see if you remember summation notation. That's very common in finance. So try to write out the formula, the sum t equals 2, superscript 5, c divided by 1 plus r to the power of t.
Please pause this video now Answer the question on a piece of paper and then continue.
And if you write it out, this is the formula that you actually get. This notation with the summation sign is very common in finance. C and R are the two input variables. T is not an input variable. It's just an ephemeral counter. It disappears. So it's just helping us with a notation. The formal definition of a simple perpetuity is as follows. A perpetuity is a stream of cash flows that pays a constant C dollars every period forever. If the interest rate is constant too, and the first payment from the perpetuity arrives in period 1, its present value has a wonderful, easy shortcut formula, and that formula is just C divided by R. Make sure you know when the first cash flow begins. It begins tomorrow. It doesn't begin today. Sometimes I put a subscript 1 on top to remind me that this is when the first payment occurs, but really I could have written C sub 25 because the cash flows here are all the same. How can an infinite sum be worth less than infinity? The answer is because each future C is worth less than the preceding C. I'm going to show you a graph on the next page, which is the present value of each future cash flows. The area becomes less and less, and soon enough, further terms add almost nothing, and thus the sum converges to a finite number. So here is my graph. In the beginning, the first bar is very big, very fat, but as you get more and more and more, the bars get smaller and smaller, and if you crunch them all together, they get so small that it actually converges to a finite number. So, what is the value of receiving $10 forever beginning next year if the discount rate is 5% per year?
Please pause this video now, answer the question on a piece of paper, and then continue.
The answer is, using the formula, $10 divided by 0.05, so it's $200. That stream of $10 each year with a discount rate of 5% forever is not worth infinity, it's worth $200. What is the value of receiving $10 forever beginning this year if the discount rate is 5% per year?
Please pause this video now, answer the question on a piece of paper, and then continue.
Well, all we need to do is add the current C. So you get one extra $10, then it's going to be $10 divided by 0.05, so it's $210. Don't need an extra formula for that. What if the cash flows also still grow a little, say just with inflation? This is called a growing perpetuity. We need to extend our formula just a little bit, not very difficult. So a growing perpetuity pays C next year. The following year, it pays C times 1 plus G. The following year, it pays C times 1 plus G squared, etc., 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 etc. So it's a simple generalization of an ordinary perpetuity. If G equals 0, it should come out with C divided by R, which is the same number. Here's a little table that shows this to you with arbitrary t, but this is not hard to guess. So here is the formula. A growing perpetuity where cash flows grow at a rate g every period has a present value of C1 divided by R minus G. It is important to memorize this formula and to be able to use it correctly. Okay, it's just a little tricky on timing, but other than that, it's really quite simple. The growth term G acts like a reduction in the interest rate. Now, this time, the subscript for the first payment matters, and that's because your payment at time 2 is different from your payment at time 1 or from any other payment, because each payment has to grow a little bit. Again, the same question: how can an infinite sum be worth less than infinite cash? And the answer is, as long as the growth is not too fast, I can still crunch up all these bars together and come up with a finite total area of this graph. But what if the growth rate is too fast? Like, say, g equals r. So let's go back for a moment. If r and g are the same, it's c1 divided by 0. That's infinite. So under those circumstances, the cash flow stream would be worth infinite. It would be taking over the universe. So under those circumstances, the formula just cannot make any sense anymore. The growing perpetuity makes no sense. The formula makes no sense, not just the formula, the cash flow stream itself, if the cash flows are growing too quickly. It's like tribbles for those of you who watch Star Trek. What is the value of a guarantee to receive $10 next year, growing by 2% per year, just like the inflation rate forever, if the interest rate is 6% per year?
Please pause this video now, answer the question on a piece of paper, and then continue.
Use the formula. $10 divided by 0.06 minus 0.02, so that number is $250. A higher growth rate means your denominator gets smaller, and therefore the expression gets larger. So it's more than the $200 we had before. Okay, let's do the next question. What is the value of a firm that pays its annual $10 tomorrow? And by tomorrow, I mean like just in 1 second. So it's not next year, although we are really doing an annuity here, or growing perpetuity, things that happen once a year. It just means that there is no discount rate on the first $10. Then it grows by 2% per year forever if the annual interest rate is 5% per year.
Please pause this video now, answer the question on a piece of paper, and then continue.
Now, there's only one little tricky aspect to this question. It's because it's $10 in a moment, and we're not counting that in the beginning. What you will get in 1 year is $10.02. So it's just a little bit more because the first growth rate has already happened. So it's a little bit more. Of course, it depends on whether you also get the $10 from tomorrow. Don't leave gifts to others by forgetting about today's payments. But that's pretty much it. So it's not, in principle, any more difficult. Now, let's say you have a startup. You expect your startup to grow rapidly. Today, it may earn only $2 million, but you project growth rates of 40, 50% per year over the next 10 years, leading to $100 million in cash flows per year 10 years from now. So in 10 years from now, you expect your firm to have annual cash flows of about $100 million per year, at least in 10 years, in exactly 10 years. Thereafter, you expect your firm to be stable. What does stable mean? Usually it means that your cash flows will grow only at the inflation rate. And for argument's sake, say it's 3% per year. You also guess that an applicable discount rate to your firm is and will remain around 8% per year. For how much do you think you will be able to sell the firm in 10 years? How much would the firm be worth today if all that it was this sales price 10 years from today? This is called the terminal value. What would it be worth? Work it out.
Please pause this video now, answer the question on a piece of paper, and then continue.
Okay, let's start by writing down the cash flows that we're talking about. C10 in the 10th year, we're going to make $100 million. C11, we're going to make $103 million. C12, we're going to make $103 million times 1 plus 3%, etc., etc., etc. So in 10 years, the subsequent year 11 cash flows may be worth, well, you have to go one period in advance, $103 divided by 0.05, so that would be about $2.06 billion. So in year 10, all the cash flows from time period 11 forward are going to be $2.06 billion. We still need to take it from year 10 and discount it back to right now. We do that by using the discount factor of 1.08 to the power of 10. That gives us about $954 million. Of course, in addition, we also get the C10 number, not the C11 numbers, but the C10 numbers. We haven't put that in here still, so we have to put that in. We also have to put in the cash flows that we get the first 9 years. However, please don't take this terminal value estimate too seriously. The eternity assumption is the least of your problem. See, most entrepreneurs are vastly over-optimistic. They think they're going to grow at this fast rate, 40%, 50%. The fact of the matter is, most firms die at this faster rate. They don't grow at this faster rate. So if I looked at this firm, if I really thought it was halfway reasonable, I wouldn't take the $1 billion that we had, or $954 million, plus perhaps the $10 million. I would think that I get an over-the-envelope estimate of, I don't know, $700, $800 million, if I believe we're really going to make this $100 million in 10 years, and it'll grow forever afterwards. So it's good enough, $700 million. The $1,000 million, the $1 billion, you can easily calculate in your head, and you just shave some number off depending on what seems reasonable to you. Now, a pro forma is basically an as-if financial scenarios. It's the standard way in which investors value startups, buyouts, all sorts of companies. They write down a pro forma, which is a financial statement, which has numbers, which has cash flows, which has all sorts of different things, and we pretend this is a scenario that we're looking at. And at its heart, we've already been working a pro forma. So we've basically already worked our cash flow projections. You would likely guesstimate the present value of your firm for an arbitrary T years, which I just told you we would have done for 10 years. More typically, people for startups do 5 to 10 years, using very detailed growth estimates where they think they can make a difference on the firm, maybe by better management, maybe by other things. So it's very detailed for 5 to 10 years. Then they're going to assume that the firm is going to have a steady state long-run growth rate, G, and they typically assume that this is just going to be the inflation rate. And then they're going to pretend that if that's what the firm is at this point, we're going to sell the firm for the terminal value. And this terminal value is inevitably calculated with a growing perpetuity formula. So this is why we need this formula, even though on some level it seems sort of ridiculous to assume that a firm will last forever. Now, you will work a pro forma for the course's final project, where you will have to throw in some terminal value like that too. Quick assessment of a firm value. I've got a firm that has earned $100,000. It stopped growing in real terms. It's the same firm. We have a discount rate of 7% per year. The inflation rate is 2% per year. Can you assess an over-the-envelope guess of the value of your firm without a calculator? Okay, go back. 100,000, 7%, 2%.
Please pause this video now, answer the question on a piece of paper, and then continue.
Strictly speaking, you will earn $102,000 next year. Alas, we're going to do this in our head, so $100,000 will have to do. So we need to divide by 7% minus 2%. That's 0.05, which is the same as multiplying by 20. Hey, even I can do this in my head. 20 times 100,000 is about $2 million. Easy enough. That's it for this video and for the valuation theory necessary to deal with perpetuities. In the next video, we'll continue with perpetuities, but a lot more practically. It turns out that there are two other common applications of the growing perpetuity formula: the Gordon dividend growth model and the implied cost of capital. See you soon. Bis bald.
My love for you is like perpetual motion.
What do you mean?
It doesn't exist.
Ouch, that hurts.